In this question about materials, we're going to look at the Young's modulus equation and breaking it down into force, area, extension, and length. Just before I start, extension is different for different specifications. You might see it as little e, change in L, which is change in length, or simply as the letter X. So it's giving you the Young's modulus, length, force, cross-sectional area, and it's also for extension. So the equation, which links all these variables is Young's modulus is equal to stress divided by strain. I'm trying to get confused with energy because a lot of students do. Stress itself is force divided by cross-sectional area, whereas strain is extension divided by length. So I'm going to use extension as X in this question. If we're doing force over area divided by extension over length, what we know about dividing fractions is that you're multiplying by the reciprocal of the second fraction. So that's the same as multiplying by length over X. So we can say that the total Young's modulus is FL over AX. But because we're interested in finding the extension in this question, I'm going to make X the subject. And I'm going to say that just swapping the positions of X and Young's modulus, we say X is FL over AE. Capital E, that is. To find the total extension due to this force, we're going to first focus on finding the extension of the steel, and then finding the extension of the brass and adding those together. So let's do that. In green first, let's find the extension of the steel. I'm just going to write S on the bottom right, just so we know it's steel. That's equal to the force experienced by the steel, which is this 80 Newton force, multiplied by the cross-sectional by the length of the steel, which is 0.8, all divided by the cross-sectional area, which is 2.4 times 10 to the minus 6, multiplied by the Young's modulus of the steel, 2 times 10 to the 11. That's an 11, by the way, it's very faint. 2 times 10 to the 11. If you put that in a calculator, that will get you a value of 1.33 times 10 to the minus 4 meters, because extension is essentially a length that you're measuring. Great. Now let's find the extension of the brass. So extension of brass, using a similar calculation, of this a bit quicker, is the force experienced by the brass multiplied by the length of the brass, which is 1.4, divided by the cross-sectional area, which is also 2.4 times 10 to the minus 6, multiplied by the Young's modulus of the brass, which is 1 times 10 to the 11. Now in a calculator, that'll get you a value of 4.67 times 10 to the minus 4. So the total extension is the sum of these individual extensions of the steel and brass. So you add these two together, and that will give you a value of 6 times 10 to the minus 4 meters. Great. Hopefully that all made sense. If you have any questions with it, please let me know in the comments. Otherwise, please be sure to like the video. It'll mean a lot. And yeah, be sure to subscribe. If you have any questions you want me to go through, by the way, just let me know in the comments as well. I'll go through them.